Okay, so we have our order pair. We have our slope is going to come from dw dt. So we'll say dw dt. Typically, we indicate if we want to insert an order pair into a differential equation, we write it this way to indicate that I want to insert 0 and 1400 if they're both needed, but in this case, it's only needing the 1400. So we'll insert to the 1 over 25, 1400 minus 300. You can use your calculator, but this is going to be 1100 over 25, which is 44. Okay, and that's our slope. Okay, we have our order pair, we have our slope. Typically, when we do point slope form, we're used to having it as y minus y1 is equal to m times x minus x of 1. But now, instead of x and y, we're using t and w, so we want it in this form now. W minus w of 1 is equal to m times t minus t sub 1. So we make our substitution. W minus 1400 is equal to 44 times t minus 0, right? We're just inserting our order pair in for T1 and W1, and then replacing the M with 44. Let's get that W by itself. Okay, so there's our tangent line equation. And then the second part of A says, use the tangent line to approximate using t equals 1/4. So this is basically linear approximation. Okay, so linear approximation just means take that 1/4 or that decimal or that fraction value, insert it in for t, and that's your approximation, right? Linear approximation means using a tangent line to approximate a certain value. Okay, thank you. Okay, part B. Find d2w over dt2. So what does that notation mean? This means what? Yeah, find second derivative. Okay, so second derivative, that means we're going to start with dw dt and find the second derivative there. So let me write this again, and we can kind of build the second derivative based off of the first derivative. Okay. Okay, it may make things easier if I just distribute this through and I have less parentheses to deal with before I find the derivative. So let me rewrite it again, dw dt. All right, let's go ahead and find the second derivative here. We know that dw dt will turn into d2w over dt2. All right, so that dt tells us that there's a time is an independent variable here. So every variable is going to be impacted by time, kind of like related rates a little bit. So what do you think 1 over 25th w will turn into if we find the derivative of this variable? Yeah, dw dt, right? W becomes 1 because that's w to the first power, but then we're going to attach a dw dt since this variable is impacted by time here. And what does 300 over 25 turn into? Just what? Just 0, right? It's constant, right? So constant will just drop out to be 0. Okay, so that's our second derivative. Our second derivative is just 1 over 25th dw dt. And let's see, is that good enough from the directions here? It says find the second derivative in terms of w. So we want the second derivative in terms of w. So we want to make another substitution. What can I replace dw dt with? Is another version of this variable. Okay, what's dw dt equal to? Can I get this dw dt in terms of w? What do you guys think? Or let me ask you this: what's dw dt defined as? This, right? Isn't this dw dt and isn't this in terms of w? So we'll just make that substitution there. So we're just gonna same thing, just being able to represent in the form that the problem asks us to do. So replace dw dt in terms of w. So this expression is in terms of w. Okay, so it says use the second derivative to determine whether your answer in part A, so that's our answer in part A, is an underestimate or overestimate. So we know that our W value is 1400. If I insert 1400 in for W, we don't have to do the math. We can just look at the number here. If I enter that in, what sort of a second derivative value am I going to get? If I insert that in, am I getting a positive or negative value? Positive. Okay, so if I get that a positive value, what does that mean visually? This graph is concave up, right? So the graph is concave up. Okay, the graph is concave up. Is the tangent line from part A, is that going to be an underestimate or an overestimate if the graph is concave up? So let's visualize it, right? Here's concave up. Any tangent line that I build is going to skim the surface of the curve. And is that tangent line going to sit above or below the curve? Below, so underestimate, right? Okay. So since our second derivative is a positive value, concave up means the tangent line is going to produce an underestimation. Okay, part C. Now we're going to move into solving differential equation portion here. It says find a particular solution to the differential equation with initial condition W is equals 1400. So we're going to try to get full separation of variables, but first I'd like to get this left and right side to be a fraction equal to a fraction. Okay, so I'm going to set up part C here. Okay, I like this right side to be visually a little bit cleaner here, so I'm just gonna move the 25 below that that W minus 300. So the first thing I like to do with solving differential equation is just to get things in their right spots. So first thing is I like to start off by getting the dw and dt in the right spots. And the way they can do that, it may not get full separation, but it will get your dw dt in a good place. So I'm going to cross multiply. Let's see what happens when you cross multiply here. So I get 25 dw is equal to w minus 300 dt. Okay, no full separation, but at least you have these notations in their right spots, right? You want everything W and anything involving W on the left side. Eventually, you want everything involving T and everything that does not have to be on the left side. We want to move to the right side as well. So anything stand out in terms of what's out of place still? Yeah, W is, we want this W together with this DW. So what can I do? Divide, right? But can I just divide the W? I need to also divide what? Now this whole parentheses, right? So this whole parentheses is going to move over to the left side. We're going to divide it over. Okay, so that's one thing. Before I do that, though, is there anything else that I could move? That 25. It's not wrong if you left the 25 on the left side. It's just that we're trying to, eventually we're going to solve for W. So anything that we can move away from the left side that doesn't have to be there, let's go ahead and do that. So I'm also going to move that 25 over. So I'm going to do a double division here. I'm going to move both my terms to the denominator of the opposite side. Okay, does that make sense? Okay, we haven't done any calculus yet, but we are setting things up where the calculus is going to be a little bit cleaner if we do it this way. Okay, so now we have full separation. Okay, so on the AP exam, you get a full point just to be able to separate the variables. If you can separate the variables, you get a point there. Okay, so dependent variable on the left side and everything else on the right side. Okay. All right, I'm going to set this up for integral rule here. I'm going to push that dw to the out of that fraction just to make it more familiar in terms of what we can do. And if it helps, I can put a 1 dt here. Okay, so what can we do on the left side? How would you start the left side here? Right, there's no integral rule that shows up right now, but we could go through what method? U substitution? Okay, what could be our U value? Yeah, that denominator, right? Okay, make our substitution there. Okay, so now it looks more familiar. 1 over u du, we know that's natural log. And then we can replace our u back in terms of w. Okay, so that's the result of the left side. How about the right side? What is that 125 will just kind of tag along, right? What's the integral of 1 dt? What's power rule? 1 becomes what? T, right? And then we also need to include what? Plus c, yeah. Okay, so technically we've solved the differential equation. We brought everything up from the derivative level to the function level, but there's still 2 things that we want to do our cleanup. So the calculus is done, but we still want to solve for w, and we still want to find a replacement for that c value, or a numeric to replace that c. You can solve for c right now if you like, but my preference is if I can get that w by itself, then I can then c will be a little bit easier, I think, without that natural log in the way. So what can I do to get that natural log to go away here? Because I do want to eventually get that w by itself. Yeah, base e. Okay, I know e and natural log have a way of undoing each other. E and natural log cancels out. I'm left with absolute value of w minus 300. Okay, we talked about how we can expand this out or clean this up a little bit. We're using this property, this exponent property, a to the m plus n can be expanded into a to the m times a to the n. So this plus sign in the exponent can be brought down as a product of 2 bases. So this becomes what? E to the 1 over 25t, then what? Yeah, times, right? Make sure that you change that operation there. It's no longer plus, it's going to now become times. You see how there's a change in operation. Exponent plus will turn into a multiplication once it's separated. Okay, and e to the c is just one big what? One big constant. I can move that constant to the front. I can also drop the absolute value because the absolute value will, that plus or minus on the right side will just get sucked into that c. And now I'll just solve for w. Add that 300 over. Okay. So I can solve for c. I can plug in my order pair. Order pair is 0, 1400. 0 is my t, 1400 is my w. So that should allow me to solve for c, right? E to the 0 is 1. Subtract the 300, I get 1100. So once I have my c value, then I can just go back and update the c value where I made that initial substitution. Okay, any questions here? Okay, if you guys can turn to page 14, very similar problem, very similar steps. So I'd like for you guys to see if you can go through page 14 and see if you're able to line up those steps similar to what we just did. So to get the tangent line equation, you want to get your order pair. To get your slope can come from the derivative. Right? All right, I'll come around and just see how you guys do there. See if I can help you out if you're stuck. Okay, so go to page 14. Order pair is 1, 2. Slope is from your dy dx. If you insert order pair 1, 2 into your dy dx, you get m equals 8. And then tangent line equation from there. Okay, part B, linear approximation. So insert 1.1 into your tangent line, and that's your approximation using your tangent line equation. Okay, so we should get 2.8 after we take that 1.1 and insert in for the x. Okay, given that y is greater than 0 and that x is positive as well, so if x and y are both positive, is the approximation greater than or less than f of 1.1? So how can the second derivative help us out here? If I know y is positive and x is also positive, my second derivative is going to be what? Also positive. If my second derivative is positive, that means my graph is concave up. Okay. If it's concave up, then we know that we can use that to decide whether it's an under approximation or over approximation. And what do we get? Concave up means our linear graph is going to, our linear approximation is going to be above or below the curve. Below, right? Concave up will be below. Okay, so since y is greater than 0, and then we're inserting a value that's between 1 and 1.1, we don't have to know what the value is, but we do know that if everything is positive, this has no chance of being negative. So if my second derivative is positive, that means my graph is going to display concave up. If it's concave up, then any tangent line that I put to that curve is going to sit below the curve. Any line that sits below the curve is going to do the job of under approximating the actual value of that curve. Okay, part C, we're going to start doing our solving differential equation. So take your dy dx, cross multiply, and work your way down to, you're trying to get from dy dx back up to in terms of y. So you're trying to involve the antiderivative. Okay, so go ahead and try that. Create a fraction equal to a fraction, cross multiply, and see if you can separate your x's from your y's. Okay, so start here. See where you can go from there. Okay, so when you cross multiply, you see your dy dx is locked in, right? So those are good. Right? We want our y is on the left, x is on the right. The only thing out of place is that y cube. Right? That y cube needs to move over to the left. Everything else is in its right place. So we'll divide both sides by y cube. We should be able to get full separation, right? Now, even though we have full separation, we have to decide how we want to set things up so that we can actually find the interval. And the hint is that both sides can be applied using power rule, but is there an adjustment we need to make on the left side before we can do power rule? Yeah, that y is in the wrong place, right? If we want to do power rule, the variable has to be sitting up in the numerator. So we're going to move that y up to the top. Okay, now we can do power rule. So power rule, add 1 to the exponent divided by that exponent. Okay, so once I go through power rule, I'm done with the calculus. And now there's two more things I've left to do. Eventually, I want to solve for y by itself. And also eventually I want to solve for c. I want to get that c to be a numeric value. I find that it's easier maybe to at least get this cleaned up a little bit more, and then I can maybe go towards solving for c. So a way to get this left side cleaned up is I can get rid of this -2. If I multiply everything through by -2, I think I can get that left side cleaned up a little bit more. So distribute the -2 through. -2 divided by 2 is just -1. And if I distribute the -2 through the right side, -2 times c is just c, so no need to include that. The -2 just gets sucked into that c there. That's good enough. Okay. Move that y down to the bottom. Okay, so I think at this point, maybe it's easier to solve for c because eventually the square root is going to show up and it just feels a little bit uglier to have to solve for c when it's under that square root. So I'm going to solve for c now. So I have my order pair, 1, 2. I'll insert 1 in for x, 2 in for y, and see if I can solve for c at this point. Okay, so 1/4 plus 1, that's 1/4 plus 4/4, that's 5/4. Okay, so once I have 5/4, I'm going to go back and replace that c value, and then maybe I can try to get that y by itself. Okay, I want that y in the numerator, so maybe I can just flip that y to the top. But if I flip that y to the top, I also need to do the same thing. I need to take this whole thing and put it in the denominator, right? So I'm going to flip both sides, but it's going to be a little bit messy, but we don't have to have a very cleaned up equation as long as we have the correct one. So if I flip the left side, I can also flip the right side, make this whole thing go in the denominator. And now, almost there, what can I do to get y by itself? Take the square root. But something happens though when I take the square root. How many solutions show up? Because of the what? Plus or minus. Okay, these are two solutions, but I only want one solution. So how do I know which solution to choose between the positive or the negative? What's going to give it away? Yeah, something about the order pair here, right? It's that y value, right? Whatever the sign of that y value is going to be the sign that we want to keep. So 2 is the only way I'm going to get a 2 if I insert into the equation is if the outside the square root is a positive value. So okay, I think we can start a little bit into our homework. So page 15. Okay, page 15, consider a differential equation. A portion of the slope field of the differential equation is given. Sketch the solution curve through the point 0, 1. So easy enough. We just identify 0, 1, and then we just follow the path of the curve through that point. Okay, part B, write the equation for the line tangent to the curve at point 0, 1. Use the equation to approximate f of 0.2. So let's find our order pair. 0, 1. Insert the order pair into the differential equation to get your slope, point slope, and then finally linear approximation, plug 0.2 in for your tangent line equation. Okay, so see if you can do part B here. Gather your order pair, find your slope, point slope form, and then insert the decimal in. We put it up here so that you can save room for part C for this solving differential equation. There's my tangent line equation. Now I can insert 0.2 to do my linear approximation. Okay, so your homework, page 16 and 17. I'll check pages, 15 and 16. So I'll check 4 pages, 13 through 16. Okay, you have the packet at home? All right, thanks.
Have a great day, guys. Thank you. Hey, Nadia. Nice to meet you today. And thanks so much. Thank you so much. See you guys. Thanks, guys.